Hello, my name is Friedel Pretorius. I'm a co-founder of Absolute Climate, but my real claim to fame is that I can turn any conversation into a conversation about MRV, and I welcome challenges to that. Naturally today, I would like to turn the conversation towards MRV. MRV comes up at just about every conference. I think we all understand it is very important, but I don't think we often enough talk about why it's so important and what it really is. Today I hope to demystify MRV for you a bit and share with you a brief introduction to the tool we've created to standardize credit assessments across the industry. What is a ton? You might think this is a silly question, but I'm not asking how many kilograms are in a ton. I'm asking you, what is a ton of climate impact? When you buy and sell credits, what is the emission impact you're transacting? When we talk about gigaton scale, how are we ensuring we get gigaton impact? This is the real heart of what MRV is. MRV stands for monitoring, reporting, and verification, but this is really just the recipe for quality assurance. Today, it's not clear what climate impact is being transferred when we exchange credits or when we talk about gigaton scales and the price of ton, because MRV isn't standardized. The ton isn't defined. The climate impact of a ton depends on the project it comes from, because MRV is designed at the project level. In this room, you probably are well aware of that your ton is different from many other tons in the room and or in the industry. So this diagram of bikers is a great example of how complicated MRV can be. It's a clear example of the role MRV plays. Carbon is everywhere. Identifying 1 ton of it is not hard, but creating the assessment of that ton that objectively represents the climate impact you claim from it is trickier. I'll let you have a stab. What is the climate impact of the stored emissions here? How do you find the mitigation here? Is it an avoidance of other fuel sources? Is it a reduction of agriculture waste? Is it a removal of the CO2 from the atmosphere? What is the project boundary and scope of the assessment? What emissions are included? Are any of those red emissions included? Because there is no standard way to assess a project, you can pick the scope, you can pick the project boundary, the baseline, and emissions that fit your claim. Depending on who you ask, you will get a different answer to this question. Existing opinions and methodologies published today disagree not only on bikers, but across projects and credit types. We see major discrepancies within registries, within credit types, within projects. Carbon credits are like a box of chocolates. You don't know what you're going to get until you bite into it. This creates problems across the board, and this is why MRV continuously is part of the conversation. So how are we going to fix it? We've developed the anthropogenic emissions model, AIM for short. It's a tool for objectively defining any project's impact on global emissions. AIM models project emissions within the criteria of a carbon cycle to determine the impact on the global carbon balance. AIM assesses where human activities are moving emissions to and from, not how. The goal of AIM is to standardize emission assessments across the industry to remove the frictions for scaling. If we centralize the MRV conversation, we can develop better standards and create greater climate impact. Carbon markets and emission targets aim to restore balance to the carbon cycle. Net zero and other emission targets are defined by the amount of emissions stored versus the emissions released into the atmosphere. AIM directly embeds this global emissions level metric of stored and atmospheric emissions into the project level metrics by directly assessing the amount of emissions a project moves into and out of storage. Measuring a project's impact on the same emission pools measured to determine global emissions ensures that the resulting project claims match their physical emissions impact. This approach also ensures that all claims are relative to global emissions and net zero targets. What does it look like? The anthropogenic emissions model, AIM, is based on the carbon cycle, which it models in 3 pools and 5 emission pathways. The pools are the stored pool, which defines all conserved carbon stocks and non-anthropogenic systems in the carbon cycle. You can think of these as the emissions stored that are accounted for in global stock takes and national inventories that if we were to release them, we would have an increase of emissions. The polluting pool refers to the reactive and dispersed emissions in the atmosphere and ocean. These are the emissions causing harm. The use pool includes all anthropogenic activities This is where the emissions that are neither stored nor polluting are housed, and this is where we scope project activities. 5 defined emission pathways, extract, release, use, capture, and store, within AIM describe how anthropogenic activities move emissions into and out of the use pool. The emission pools and pathways allow any project emission to be modeled clearly and objectively using this framework. The emissions are clearly defined, the baseline is embedded, the scope is always the net use pool. So here's a really generic example of an emission assessment using AIM. Making an assessment is as easy as 1, 2, 3. There's no counterfactuals to be used. The scope and baseline are embedded in the model. All that is needed is to plug in the project emissions. Primary and operating emissions are mapped in the emissions pool, and what we require is that the primary emissions equal what goes in, what comes out, so we have a mass balance equation going on, and the emission balance is calculated by looking at the net changes in the stored and polluting pools. So really we're asking, great, this is what your project looks like. How many emissions did you move out of storage into the polluting pool, or how many did you move from the polluting pool into storage? Climate impact and credit type is then designated on this outcome. So we define 3 outcomes from this, which we're in the presence of releasing a broader standard around this, and there'll be more information on what these credit types mean. But for now, we'll categorize them as these 3. So you have an emission, which is really obvious. We take emissions from the stored to the polluting pool. And then we have net negative impacts, which is what we're calling a restoration, a defendable negative emission taking emissions from the polluting pool to the stored pool. And thirdly, we have recoveries. So this is emission pathways that create a net zero loop, returning emissions back to their source. So you can think of this as CCS and CCU. Recoveries create pathways that are oftentimes part of another net emitting activity. Coming back to our bikers diagram, we can show how the typical bikers methodology assessment is often scoped compared to how it would be scoped within AIM. So on the left, you can see the project level scope, where we only look at the emissions being stored. We disregard where those emissions came from. We disregard all the emissions associated with transporting and processing those emissions. Versus in AIM, we look at, great, the stored emissions, and we ask, where did those emissions come from? And we trace them all the way back. AIM doesn't just look at the flux of emissions stored, but rather traces those stored emissions back to their origin in either the polluting or stored pool, and accounts for the overall impact of the carbon cycle. A project-level assessment might ignore that even though crops absorb carbon as they grow, they often produce more emissions than they capture from fertilizer use, tilling, transportation, and processing. AIM ensures that these impacts are considered by ensuring emission scopes match their claim. If the project claims to capture atmospheric emissions and store it, then the assessment should also extend from atmosphere to storage. So, the anthropogenic emissions model provides an emission assessment consistent with physical science. It assesses the entire emission stream, not just the scope of it. AIM creates a mathematical, objective, and universal determination of project impact. Carbon is carbon. It doesn't matter what technology moves it, it matters what impact is created. Thank you.